Okay, good morning. So I want to solve some more problems for you regarding the factoring polynomials, and then I will give you most of the time for today to practice on your own. Let me start with an example to see what is your opinion about it. For example, I give you factorize this. So 2x to the power of 5 plus 4x to the power of 3 and then plus 2x. So I give you this and I ask you to factorize that, and I always mean factorize as much as possible, even if it is not explicitly mentioned, yes? And I told you, if you remember, you only know 3 techniques, but Ali asked me a question in the book, so I realized that in some exercises you need to know something more, so I will complete it today. But the first thing we learn in factorizing is that, is there any common factor which is common to all the terms that has priority to whatever we learn afterwards, yes? So if that is the case, you shouldn't think even 1 second. If you see that you can pull out even one single number out, do it first and think about the rest later, yes? So for example, if I give you this, you see that there are 3 terms involved. You might think that this should be related to the squaring pattern, but for a squaring pattern you also need to complete the squares, which it is not here. But I told you that the priority is not thinking about, is there something that I can factor out from all the terms? If the answer to this question is yes, try to conditional your brain in this way. Whenever you want to factorize a polynomial, the first question that you ask yourself should be this. Is there something, a factor, that I can pull out from all the terms, not partially? Yes? If the answer to this is yes, do that one first and then think about the rest. Okay, so here, the answer to this is positive, yes? What can I pull out? 2x, yes? So 2x is a common factor to all these. So you open a pair of brackets, and then you divide this in your head by what you pulled out. So what is the answer? X to the 4, yes? And if you want, you can multiply it back to see that you haven't done any mistakes. 2x times x to the 4 is 2x to the 5, so that's correct. Then I have plus. Again, in my head, I divide this term by what I pulled out. What is the answer? 4 divided by 2 is 2. X to the 3 divided by this x is x squared. And finally, I divide this by what I pulled out, but hopefully you agree with me, that would be 1. I really recommend you to check that you have done everything right by at least thinking about, if I multiply this back, I will get this one. So if there are 2 points for this in the exam, by doing this you will definitely get one of those, yes? But it is not complete here. If you stop here, it means that you haven't recognized the squaring pattern here, because there is a squaring pattern involved, yes? Why is that? Because first of all, I have 3 terms involved, good. 2 of them are complete squares. But this doesn't guarantee by itself that this is a squaring pattern unless we go to a scratch paper or do it in our head. Take the square root of this one, it gives you x squared. Take the square root of this one, it gives you 1. Multiply these 2 and multiply it 2. What is the answer? The answer is 2x squared, which is exactly the middle term. So that is the real squaring pattern. So what is the answer to this problem then? It becomes 2x, and then you write x squared. Because this is addition, you put a plus sign, and then the square root of that is 1. So this is the finalized form which I expect you to write if I ask you to factorize this. Is that clear? Okay. Let me give you another problem to see what do you do here. What can I write for this? 4a plus b squared minus 12 a plus b plus 9. Yes? And again, let me tell you that I am asking you to factorize that. For this problem, I can ask two different questions in the exam. I can give you this, and I ask you to expand it. I can give you this, and ask you to factorize this. I want you to appreciate the difference between these two questions. If I ask you to expand this, so let me write it in this way. It is good to have it. Expansion. I might give you this and I ask you to expand that. Then what does it mean? It means that you need to remove all pairs of brackets. So then it means that here I use a squaring rule to expand, not to factorize. This gives me the first one squared, 2 times the first one times the second one, and then the second one is squared. And then here I multiply minus 12 in, minus 12a, minus 12b. I am multiplying minus 12 here and there, and then I have a 9. But this expansion is not finished because I have one pair of brackets left, so I multiply 4 inside. So this is one possibility. Expand this. That is the solution. But sometimes I ask you to factorize this. Factorize doesn't mean to remove the pairs of brackets. On the contrary, you have to collect them as the product, as a product. So let me give you the same question, but change it from expansion to factorization. Okay, now I want to hear from you now, because expansion was easy, I did it myself. But now, can you tell me how can I factorize this? Factorize means write an expression which is equal to this, but it is in a product form. How can I do that? Yes?
It's a squaring pattern.
It's a squaring pattern. So you need to broaden your perspective. So you need to train yourself. So you need to work with patterns, not names. Yes? So that is actually a squaring pattern, but this plays the role of the first. So you see, you might say this is not 3 terms. Yes, you see there are many terms involved actually. But it can be viewed as 3 terms. Yes? 1 term, second term, and the third. So here, this is completely squared, and that's completely squared, yes? So it motivates you to think about a squaring pattern, but you need to convince yourself of that. You take the square root of this, so it becomes 2a plus b. You take the square root of that, it becomes 3. You multiply these two, and you yourself have to multiply by a 2 all the time because of the formula. So 2 times 2 times 3 is 12, a plus b. And that is exactly what is sitting here. So that is also a squaring pattern. It means that I can write it as a power of 2. But the middle sign is negative, so I have to put negative here. The square root of this is 2a plus b. Square root of this is 3. So this expression is equal to this. So these are higher level questions, but it is not that hard that you don't understand. Is that understandable for everyone? Yes? Okay, but you shouldn't stop here, because I have an extra pair of brackets unnecessarily there. So I just get rid of it by multiplying this in. This becomes 2a plus 2b, but I have a negative 3, and the total expression to power 2. So that's very interesting. You see, this expression can be written as this expression to power 2. Yes? And that's it. So I want you to also understand these types of questions. For example, let me write one more for you here. What do you think here? Is this a squaring pattern or not? So, for example, x minus 2y squared, and then I have minus 10x minus 2y, then I will have 25 at the end. Yes? I hope that by looking at this, you immediately can recognize the pattern of a squaring rule. Yes? It is not three terms, I agree, but you can view it as three terms. One term, two terms, and the three terms. Yes? And then hopefully you see that two of them are complete squares. If I want to be sure, I go to a scratch paper, take the square root of that, it gives me x minus 2y. Take the square root of that, it gives me 5. I multiply them, and I multiply it by 2. This becomes 10x minus 2y, and that is exactly the one in the middle. So that is really the squaring pattern. So the answer to this would be squared. This is negative, so I put a negative sign here. Square root of this is x minus 2y. I really don't need to put any pair of brackets here because nothing is behind that. And then the square root of this is 5. The answer is very simple. Okay, so remember this trick. So when I say that you need to detect patterns, this is the meaning. Yes, it is quite different from a squared minus 2ab plus b squared. Yes, the way that I have written it here is different, but the pattern is the same. Okay, so you see, I forgot to write. This is factorization. That's expansion. I appreciate the difference between them. And now I want to give you some examples related to the conjugate pattern. Yes. Okay, so let me give you a nicer question here. So I want you to factorize this. So a squared plus b squared to the power of 2 minus 4a squared b squared. Okay, can you see the conjugate pattern involved in this problem? Because I told you, conjugate pattern, don't be distracted by the names and things. You need to detect the patterns. The pattern is something squared, whatever is inside I don't care. And something else squared, whatever inside I don't care. What I care is that I have the difference of two complete squares. Whenever I have this pattern involved, this should remind me about the conjugate pattern. Okay, so is it this pattern or not? Yes. So we can write it as a squared plus b squared squared. Instead of 4a squared b squared, I can imagine this is 2ab squared, yes? The reason that I am writing it in that way, you don't have to, but I want you to see the pattern crystal clear in front of you. So this is playing the role of the box. This is playing the role of the circle. If you do not look inside, you get this pattern. Yes? And what is the answer to this pattern? The factorization of this is you take a square root of that one, take a square root of this one. Once you put negative between, once you put positive. So I will do the same thing here. So what happens? It becomes two pairs of brackets. I take the square root of that, I put it here. Take the square root of that, I put it here. And here as well. I told you, once negative, once positive. So it is factorized now, because this expression is written as a product. But is it complete? No, why not?
There's two brackets. Or
So yeah, the brackets I can remove, yes? The reason that I can remove the brackets, because I don't have anything behind them. So let me just remove them. But still, is it complete? Yes?
Well, on the second one there's a squaring pattern, and on the first one as well. But yeah.
Yeah. So this is also a squaring pattern in a little bit unorganized way, yes? That's also a squaring pattern. You need to remember, if you do this, it's not finished yet. So I have to continue. This can be written as a power of 2. This is negative. I put negative, so it's a minus b. And then for this one, it is a plus b. So this is the complete version of factorizing this. Is that clear? Okay, so I want you to, because it doesn't matter how many examples I bring in, so you need to try to teach yourself. So the goal is not following the rigid rules. The goal is to understand the patterns. Okay, let me give you another example. So what do you think about this? 3x to the power of 5 minus 48 xy to the 4. How can I factorize this? Yeah, so I told you that. Try to conditional your brain, yes? Whenever you can factorize something from the whole expression, do it first, without thinking. Can I factor something out? Yes, 3 and x is the expressions that I can pull out. So this, I will do this. By this one, you guarantee 1 point for yourself. Okay, and then make the rest of the problem easier. I pull 3x out, I divide this in my head by that, the answer becomes x to the 4. And make sure that you have done everything right by multiplying it back in your head. Okay, and then you have negative sign here, you divide this by 3x, it becomes how much? 16y to the 4. This is one step. It is already in factorized form because it's a product. But it is not complete. Might be it is not complete. You need to think. Might be it is or might not. So here I see that what pattern is involved here? Conjugate pattern, because that's the difference of two complete squares. So what I need to do, I copy and paste the first part. I put 2 pairs of brackets. Take the square root of that, x squared. Take the square root of this is 4y to the 2. Once here, once there. And it doesn't matter where do you put the negative sign, the plus. So, is it finalized?
No.
No. Because now another conjugate pattern emerges. So you have to continue. Yes? So then it becomes what? 3x. And then it becomes x 2y. X 2y. You see, I'm taking the square roots. I have to copy and paste this part. I told you that the sum of two completed squares, you cannot factorize it unless you use the complex number that we will study future. So whenever you have the sum of two completed squares, don't worry about it. Just copy and paste it. But here I have to minus and then plus. Can I factorize it more? Hopefully you agree with me that no, that's at the end of the problem. So this expression is fully factorized. How many factors are involved? 1, 2, 3, 4, and 5 factors. Yes? Okay, now I want to teach you something like this. I have seen Ali ask me, so I saw that there are some exercises in the book, and that's actually good to know. For example, if I give you this, AC plus A, let me write plus AD here. And BC here, and BD here. Okay? So, if I give you this and ask you to factorize it, apparently none of the patterns will work here. Because first of all, can I pull something out? The first thing that you need to think about every factorization is that, is there some factor that I can pull out from all the terms? The answer is no. A is common between these two, but it's not common for all of them. C is common between these two, I don't know. b is common between these two, but nothing is common for all of them. So I cannot pull something out, so the first priority is gone. But do you see any squaring pattern left? Apparently not, because in a squaring pattern, first of all, we need 3 terms, okay? So secondly, we need how much? We need 2 completed squares, which we don't have. And then is it a conjugate rule? Still no, because in the conjugate rule, I need the difference of 2 completed squares. So there is a lot of actually tricks for factorizations. If you are interested to understand it more, you can see my videos on my YouTube channel. But at this level, I want to teach you this. Sometimes you need to be a little bit observant. You see, I take this one, for example, with that one, but this is not important. Try to be patient and see what it brings for you. Can I factor something between these two only?
Yes.
Yes, and that is C. Can I factor something between these two? And yes, the answer is D. But this is not the important. You need to look a little bit ahead of yourself. Why? Let me just do that. I pull C out. What is left? It's A plus B. And I pull D out here. What is left is A plus B. Yes? Well, now look, can I claim that I factorized my expression? No, because it's a sum. Yes? If I ask you to read this expression, you would say that this is the sum between this and that. It's not a product. But I have chosen this wisely by practice. This will come by practice. By the way, it's not easy. If you make this complicated, I will have myself problem understanding it. Okay? But for these simple problems, it is not hard. The point is that categorize them, group them in a way that first of all you have something in common to pull out, but that's not the important step. The important step is that after you do the factorization in each group, you see something common emerges. So you need to look a little bit ahead of yourself. Why is that? And then I can factorize it, yes? I can pull A plus B out. Do you remember we practiced about these things yesterday? So A plus B goes out, and then I will be left with C plus D. Now, can I claim that this is factorized form of that?
Yeah.
Yes, because now it's a product. So this is a little bit hard if the expression is complicated. So I want to give some examples together that we can practice. Can I change my grouping? Sometimes the answer is yes, sometimes it's negative. For example, in this case, let me change my color. I could take this one with that one. I could take this one with that one. That also works. But sometimes if you change the grouping, it will not work. Let us see if it works in this case or not. If I insist to take this one with that one, I can pull A out between these two. From here, C is left. From here, D is left. And then between these two, I can pull D out. So from here, C is left. From here, D is left. Is it a good grouping? Is it successful? The answer is yes, because after doing each step, I seek a common factor emerges. And when a common factor emerges, I can pull it out. Then it is left A and B from here and there. But I hope that you agree there is no difference between this and that. So for this problem, if you group it according to these blue lines, that is working. If you are grouping, if you are working according to these green lines, that's also working. Yes? Now I want to give some exercises that you can practice here a little bit. Let me see. Okay, what do you think about this problem? I give you this and I ask you to factorize it. B squared y minus b squared minus a squared y plus a squared. Okay, can you help me to do this? This expression I want to factorize. Let me just repeat these things so that you can conditional your brain, make it conditional, okay? The first thing about every factorization is this question. Is there any common factor common to all the terms here? The answer is no. So the first step, the answer was negative. So there are only three more techniques for you. Either it should be a squaring rule, or a conjugate rule, or this grouping rule that I just taught you about it. Yes? So I hope that you agree with me. This is apparently not a squaring rule, and I hope that you agree that's not a conjugate rule either. Yes? So the only hope that we have to factorize this is this new method. For this new method, sometimes you have to do trial and error. Okay? So it means that you need to check in which way I can group them that it works. Yes? So do you have any suggestions? Yes, Ali?
by and b, and they can be
B squared y minus b squared, you mean? Okay, for example, let us test. You need to get used to. Sometimes it is not possible to find the answer to the problem in mathematics directly. We have to do trial and error. So here, that's at least what Alice said is meaningful, because we see a common factor between these two. That's good. And then what do you say? Probably you want to take these two together. Okay, so let us do this. If I take these two, I can pull b squared out. I can pretend momentarily that I don't have this part. I have only this part. This becomes y minus 1. So far, so good. And then, what can I pull out between these two? Can you tell me? Yeah, you might say a squared. If you say a squared, that's not wrong, but it becomes minus y plus 1. You might think that this grouping is wrong, but it is not wrong. I can fix it. Yes? Because this is minus y, this is plus 1. What I needed was positive y, negative 1. I told you several times, whenever you have this problem, you need to think about pulling a negative sign out. Yes? So instead of taking positive a squared out, which will not work in this case, what I pull out is negative a squared, and then instead of minus y being left, positive y is left, but then it becomes negative 1. I really recommend you to double check. Minus a squared multiplied by y, it is minus a squared y, that's correct. Minus a squared multiplied by minus 1 is positive a squared, that's also correct. So what I have done is good. But is it a successful grouping? It is, I will call it successful, because after factoring in each group, a common factor emerges. Okay, so what can I do here? I can pull it out. It becomes y minus 1, b squared minus a squared. Is that understandable? I pulled y minus 1 out. From this one, b squared minus a squared. Yes? But is the problem finalized now?
yes.
No, because suddenly a conjugate pattern emerges. So what happens is becomes y minus 1, and then it becomes b minus a and b plus a. And that is the fully factorized form of that expression. Okay, is that understandable? So I told you that factorizing polynomials, you have to be very creative sometimes, but this is good to know about it. Let me see if I can give you another example. I can give you a little bit harder one if you are working for a challenge. So here I have this. I don't think it is in the book at this level, but at this level it was. Yes. But let me write something here. Can you tell me how can I factorize this one? X squared plus 10y minus y squared minus 25. This is tricky. Okay? I want to give you a little bit of time to think about it. How can I factorize this expression? It seems very innocent, simple, but you need to be a little bit more creative than that one. The idea is still grouping, but you have to be a little bit more smarter here to see how the grouping should be. I give you a little bit of time to think about it. The people at home, if you are interested to work on, please take a note, because when I pause the video, you will not be able to see what's written on the board. X squared plus 10y minus y squared minus 25. I want you to factorize it. I consider this a hard problem. Let me give you a hint, because I just gave this example immediately after these two problems. I think all of you are thinking about grouping them 2 by 2. But that is not, are you thinking differently?
Well, I tried.
Yes, that's good. At least you tried. So this doesn't work 2 by 2. I couldn't find any way to do it 2 by 2. But you can group 3 of them and 1 alone. That is my hint for you. You need to put 3 of them in one group and 1 alone and see what happens. Yes? I want you to think again. Of course, I can solve the problem and it becomes easy, but I want you to discover it yourself.
What is this? For these omens variable.
Okay, could you do it? Yes? Yes, Hafsha, let me ask you this time. Yes.
So the last 3.
Yes?
Yeah, those I could like see some patterns and then but the first I did was I multiplied everything with a negative sign.
Not multiplied, pull a negative sign out. If you want to multiply, because this is not equality, you cannot change it. If you have equality, you can multiply everything. But what probably you mean is right. It means that you write this x squared. This is very similar to a squaring pattern, except that we have the wrong signs for these two. So this will motivate me, and everyone probably, to take a minus sign out. So this becomes y squared. This becomes positive 25. But then this was already positive. It becomes negative, but I don't have any problems with that. Yes? So first of all, I want you to see what I have written here is exactly the expression that I gave it to you in the beginning. Yes? Because this minus sign behind the pair of brackets is for this one, for this one, for that one. If I multiply so x squared is x squared. If I multiply minus sign here, it becomes minus y squared. That's right. If I multiply minus here, it becomes positive 10y, which is right. And if I multiply this, it becomes negative 25. So I hope that everyone agrees what I have written here is really equal to the one that I gave it to you. Yes? But what is the benefit of doing that? Because this becomes a squaring pattern. So this becomes x squared minus y minus 5 squared. Let us take your time. Do you understand what I have written here? Yes? Is that understandable?
Yes.
But can I claim that even though this is really equal to this, but I can claim that I factorize it? Yet no. Because that's the difference. But what pattern becomes involved here? What's that pattern? Conjugate pattern. Yes? That is the difference of 2 complete squares. So this means that I open 2 pairs of brackets here and there. I take the square root of this, take the square root of that. Once I subtract them, once I add them. So that is the factorized form. But it is not simple. I can simplify it by removing these unnecessary pairs of brackets. So you have to be careful now. So what I do, I write x. I multiply this minus sign in, it becomes negative y, but plus 5. And then this becomes x. I just simply remove these pairs of this pair of brackets because there is nothing behind that. So this is the factorized form of that expression. Yes? So you see, you need to practice if you really like to improve your skills in factorizing polynomials. So I wanted to end the lesson today now, but let me give you 2 more, at least you can practice a little bit. So I just... I want you to do this one for me as well. Okay, so let me give you 2 more and then I will end the lesson definitely. So here, what do you think about this? Now you have a little bit more experience. Do this one for me. X to the 4 minus x to the 3 minus x squared plus 2x minus 1.
Åttorna är en av de svåraste.
Yeah, do this. Okay, let me write one more and then give you a little bit more time. This is one of them. The other one is this, x squared plus 4 to the power of 2 plus 8x times x squared plus 4 and then plus 16x squared. Yeah, I can give you some time. If you are not interested in hard problems, you can follow my Google Classroom advice recommendation. Yeah, I will not give you these type of questions in the exam. Might be I can give them as a bonus question. But I want you to practice if you want to. If you are not interested in harder problems, don't spend time on it. But don't waste your time. Please go to the Google Classroom and follow the instructions there. Okay? After 10 minutes, I will solve both of them for you. Okay, so what is your opinion about, because I want to solve it and then you can practice on your own. So do you have any idea what to do with the first one, or at least partial ideas? What about the first one? Do you have any idea what to do here? I was expecting you should be able to solve this one. It's not that different from what I did. Actually, I think, no, here. I'm not saying this is the same problem, but the same idea somehow works here as well. Could you detect that idea somehow? Yes, Rasmus, you want to say something?
And with the X last 3 terms kind of look like an...
The first 3 terms?
No, the last 3.
Last 3, okay, that's
Like,
good. So it means that you are taking these 2 and then these 3. Let us do the grouping like this.
Yeah.
Okay, so what happens here, I can take x to the 3 out, which we don't know yet if it is going to work or not, but this is one way to do it. There are many alternatives, you know, to try to do the trial and error, but that's the fun part of the one problem. So what I have, I hope that you agree, this is very similar to a squaring pattern. Again, I have the wrong sign for the squares. So this motivates me exactly to do the same thing, pull the negative sign out. So then what happens, this becomes positive x squared, this becomes negative 2x, and then this becomes positive 1. Yes? So, but this one is a squaring pattern, so I copy and paste this part. Then I write it as x minus 1 squared. Hopefully everyone agrees. The first one squared, 2 times the first one times the second one squared. But can you consider this a successful grouping? Yes, because a common factor eventually appears. X minus 1 is here as a factor. I have 2 factors of x minus 1 here because that's a power 2. So a common factor appears. So this means that I can pull the common factor out. So what is left for me is x to the 3 minus what is left from the second one. I had two factors of x minus 1. One of them is pulled out, one of them is left. But this is unnecessary, so I remove it. So this becomes x minus 1, and then I have x to the power of 3 minus x plus 1. And that is a factorization of this. Of course, you might ask, how should I know that this cannot be factorized more? At this level, you don't know, but I know that this is not going to be factorized more in the set of real numbers. So this is the end of the problem. But could you detect, that is a little bit harder one. Could you detect this one? How should I do that? Do you see any pattern right away without changing anything at all? What are the patterns?
Square.
Oh, okay, thank you very much. So this is without any changes. It's a squaring pattern. Yes, why is that? Because I have 3 terms involved, not 3 terms. I can view it as 3 terms. Yes, and the third. 2 of them are complete squares. So this will motivate me that might be, this is a squaring pattern. But how should I be confident about that? I go to a scratch paper, I take the square root of this guy, it becomes x squared plus 4. I take the square root of this guy, which is 4x, I multiply them, and I myself multiply it by 2. Then what happens? It becomes 8x, x squared plus 4. So this is exactly what is sitting in the middle. So that is really a squaring pattern. So what happens? This becomes equal to, so I put this one to power 2, the square root of this one as the first term, plus the square root of this one as the second term. But this is unnecessary. So let me remove it. But is it finalized? No, because there is another square pattern emerges. Yes? So what happens? I have a power of 2 up top there. This is a squaring pattern, unorganized, but that doesn't matter. So this becomes x plus 2 to the power of 2. Yes? And then no one writes to the power of 2 to the power of 2. What's the best way to write it? Plus to the power of 4. So that is interesting. This expression is nothing except x plus 2 to the power of 4, which was not clear from the beginning. But if you master this factoring skills, you can just immediately realize it. So I will not give these type of questions in the exam, of course. I will keep it at the level of the book. And there are also some nice questions in the book. If you follow what I have written on Google Classroom, you will actually enjoy solving them. Okay, thank you. So I stopped this being recorded, so and then you practice on your own. Thank you very much.